Okay, so let's talk about how cluster sampling is different than stratified random sampling. With a cluster sample, so stratified random sampling, think of your 10 bins, okay, and then within each of those 10 bins, you're going to take a simple random sample. So your final sample has individuals from each of the 10 bins. With a cluster sample, you divide the individuals into groups. Now, with stratified random sampling, usually the groups, each group has similar characteristics. So maybe you have group with red hair, brown hair, blonde hair, orange hair, black hair. And so your final sample is going to have individuals from each of those 10 different groups of different hair colors. But with a cluster sample, we divide the individuals into groups that don't necessarily have the same characteristics. So that just means your groups of 10, now instead of each group being different, each group of 10 mirrors the entire population. So each group of 10, so your first group of 10 isn't just going to be everybody with purple hair. It's going to have everybody with purple hair, blue hair, green hair, blonde hair, black hair, brown hair, whatever, in that same bin. And you would have 10 bins of those. All right. The cluster, the important thing about cluster sampling is it has to have the same characteristics as the population. So each cluster is varied, so that means they're not all exactly the same in each of the 10 bins and is a good representation of the entire population. If it's not a good representation of the entire population, then using cluster sampling is not an accurate method to sample. Why would we do this? Number one, it's often used for practical reasons and to save time and money. This is easier to use when the clusters look like the population that you have, but are on a smaller scale. Now, for example, let's just say we have 10 clusters. Here's how this works. So you have your 10 bins. We're taking a simple random sample of 3 clusters. Our sample is everyone in the 3 clusters. So if I have 10 different bins, I'm going to throw numbers 1 through 10 into a hat, pick out 3. Let's say pick numbers 1, 5, and 7. So bins 1, bin 5, and bin 7. Everybody in those 3 bins are going to be part of your sample. The other bins, the other 7 that we didn't use, sorry, they get no representation in the sample. So this is different from stratified random sampling in the sense that stratified random sampling, they group by similar characteristics. So like everyone with blue hair would be in a bin, everyone with red hair, everyone with black hair, everyone with brown hair, versus cluster sampling, the bins would have like a mix of all of the hair colors. Okay, and with stratified random sampling, remember we take a simple random sample of each strata. So each strata is represented in your final sample, where with cluster sampling, just some of the stratas are represented in your final sample. Okay, just remember that clusters always mirror the population, but on like a smaller scale. So it's like taking your population and shrinking it. And then you take a simple random sample and pick a few of the whole clusters. Unfortunately, some will be left out. All right, so go ahead and take a minute and read this, hit pause, and then answer the next, see how you answered the questions regarding the beachfront hotel. Okay, so now this hopefully will explain the difference between your simple random sample, your stratified sample, okay, of 88 rooms, and a cluster sample of 88 rooms. All right, so number one, for a simple random sample, just remember putting everybody in a hat. So each room gets labeled 01 to 880. All 3 are the same length. So you're putting all numbers in a hat, pick 88 out. Okay, or you can use the random int or random integer table to select 88 rooms. Remember to ignore repeats because we don't want to have the same room twice. Now, how would this look differently if it was a stratified random sample? So you have to choose your strata. Now, remember the strata is naturally occurring groups. So in this case, we're going to stratify the towers by north and south. They're already in groups of the north and south. It's important to get an even number of samples from the older and the newer towers in order to get a full perspective. So same thing, in each tower, we're going to label them 001 to 440, 3 digits, and then we're randomly selecting 44 rooms from each tower to get a sample of 88 rooms. So this guarantees us that we are going to have rooms that are facing the beach and some that are not facing the beach. That strata is naturally occurring, okay? It's naturally occurring strata, so I'm making sure that my final sample is a good representation of the population. Okay, the other way to do it is divide it into clusters. Now just remember, a cluster is a naturally occurring group. In this case, we're going to define the cluster or the strata, sometimes it's still called strata, into each floor. So the floors are labeled 0, 1 through 12. All right, so 2 digits, and then we're randomly selecting a floor. You can then sample all of the rooms on that floor. One drawback, so then you're going to take 0, 1 through 12. You're going to sample every single room on that specific floor. So there are floors that would get left out. One drawback is that you might get a suite floor level, and it's likely that those customers are going to be more satisfied than those customers in a standard room. Okay, so the drawback to that is, like I said, you, instead of making sure that you have rooms of every type, you could potentially have rooms that are all suite levels. Okay, and in this case, went back. You'd have to choose how many floors you were going to select, so some floors would be completely left out. All right, so go ahead and try this one. This one is describing how you would use simple random sample, stratified sample, and cluster sample to select 80 students to complete a survey. All right, so in this case, we have 9th graders are seats 601 to 800. 10th grade seats are 401 to 600. 11th grade are 201 to 400. And 12th grade are 1 to 200. All right, so we want 80 students to complete a survey. How would you do it using each of those 3 methods? All right, so number 1, remember simple random sample. You have to throw everybody's name in a hat. So we're choosing 80 of the seat numbers at random. So you could use random int 1 to 800 because there's a total of 800 seats on your calculator, and until you find 80 different seats. So just make sure that you're stating ignore repeated numbers, okay? Or state that you're choosing 80 different numbers. Give the survey to all the students in those seats. All right, another way to do this is by using your stratified random sample. So they're all seated by grade level. That's a naturally occurring strata. They're all similar. Okay, so like I said, with stratified random sampling, they're usually similar. Because the students' library might be similar within grade levels, but different across each grade levels, we're using the grade level seating as our strata. So within each seating area, we're going to select 20 students at random. So from the 9th graders, we're going to do random int 601 to 800, select 20 seats from there. And we're going to repeat that with each of the classes. So that's going to guarantee that we're going to have 20 students from each grade as part of our survey. Okay, the way to do this using a cluster is with the way the students are seated. Like I said, still has to be naturally occurring. Each column of seats from the stage to the back of the auditorium could be used as a cluster, so working backwards. Now, each cluster, keep this in mind, has students from all 4 grade levels, so that's a good representation of the population. The cluster is not all the same grade level. They have different representations. They include all 4 grade levels. So then there are 20 clusters, each have 40 seats. All right, so if you have 20 clusters, each have 40 seats, we need 80 students. We're choosing 2 of the clusters at random to get 80 students for the survey. So that means even though there's 20 clusters and we're only choosing 2 of them, 18 of those clusters are not going to be represented in the population. So think of 20 bins, you're choosing 2 bins. Everybody in those 2 bins are going to be part of your survey. The rest aren't, okay? And then you're going to use random int 1, 20 to select the clusters. All right, you're going to do that until, make sure you say ignore repeats, all right, until you have 2 different numbers. And then you're going to give that survey to all 40 students in that column of seats. All right, so why do we need to do sampling? The purpose of a sample is to give us the good information about the larger population. We need a good sample for a good representation. So the process of drawing conclusions about a population on the basis of a sample is called inference, and that's basically what statistics is we're taking a sample or we do a test in order to make an inference or to make a conclusion about the population. So why do we rely on random sampling? Number 1, it helps us to reduce bias. So that just means we're not overestimating or underestimating the answers, okay? But it's never going to completely eliminate bias. So remember, sometimes we'll have maybe One answer is too big, one answer is too small, but then they even each other out. Okay. The laws of probability allow us to make trustworthy inferences. So basically it's just saying the laws of probability allow us to take the information from the sample and apply it to a larger population based on the margin of error. So all results from random samples come with a margin of error. All right. So margin of error just means like, okay, I got this sample. I got the mean amount of time students spend on a computer is 1 hour, but there could be some error. All right. So we're going to give a sort of a range on what that error could be. So maybe it's really 0.75 to 1.25. So we have a plus or minus 0.25 margin of error. Okay. The laws of probability tell us how much sampling variability there is. They don't correct for bias. All right. So they don't correct for complete overestimates or underestimates, but just for naturally occurring variability. So like I said, one that's too high, one that's too low, averages each other out. It is not a mistake that is made in sampling. So the laws of probability make sure there's not a mistake that's made in sampling. All right, so margin of error, what exactly is that? So how can we reduce variability and reduce our margin of error? So like I said, if we're looking at how the mean amount of time spent on a computer, maybe we don't want the margin of error to be 0.25 too high or too low. We want to make sure that when we take a sample, it's as close to the population mean as possible. So that's what it means by reduced variability. We want our sample to be as close to the population as possible. How can we do this? We can increase the sample size. Well, what does that do? When we increase the sample size, we're getting a better representation of the population. So reducing that variability means that the answers are going to be similar to the population. Okay, so there's not going to be a wide range of answers from the sample that are going to be different from the population. What can go wrong? Many sample surveys are affected by errors in addition to the sampling variability. So sampling variability just means when you take a sample of 10, what is the mean amount of time? When you take another sample of 10, what's the mean amount of time you spend on the computer? Another sample of 10. Okay, so we want that sampling variability to be low. We want to get about the same mean each time. But we can have errors that can affect that sampling variability. One of those is under coverage. All right. That means, remember, that we don't get everybody in the population. So sampling variability simply means that when you take a sample, you may get a wide range of answers within your different groups if you don't sample correctly. So good sampling techniques include all kinds of art. So it's like an art and how to reduce sources of error. Okay, so it's just a funny comic for you to take a look at. All right, here's a summary. Just go ahead and take a minute and read these over. And that is the end of section 3.1.